Welcome to Resilient PNT 360 and 180, where we give you a 360-degree view of a topic in 180 seconds or less.
So I'm Lisa Perdue. I'm the product line director here at Aurelia for simulation. So in traditional products where the FPGA is normally generating the signals, there are what we call fixed hardware channels. So when you program the FPGA, you can only generate so many signals out of that. So if in the case of like the GSG5 or GSG6, we're limiting ourselves per board to 16 channels. That means we can generate 16 signals out of that board. With the GPU, due to the different architecture, we're able to generate many more satellites, and we're not constrained by any type of hardware channels. So when you get a simulator that's powered by the GPU, you really get what we call all-in-view satellites. So you don't have to choose or make a trade-off between price and the number of satellites you're able to simulate. You are able to simulate whatever you would see in the sky. If that's 12 GPS and 10 GLONASS and 10 Galileo, you're going to see them all when we're using the GPU. You don't have to purchase additional modules or additional FPGAs, additional channels in order to get those. With the GPU, we just utilize its processing power to show all of the satellites. When we say SkyDel Everywhere, what we're really talking about there is SkyDel is a software. So we can run it on multiple different hardware platforms. We don't have to design that hardware ourselves. We can utilize hardware that's already available on the market. So we can use the same software in a very small form factor, like an Intel NUC computer, and generate signals from it using SkyDel, or we can do it in a big system, like a multi-element wavefront system, where we're testing advanced anti-jam antennas, and we're running the same SkyDel software. So we're able to scale up and use SkyDel in the lab, at your house, everywhere. Anywhere that you want to do your testing, you're able to use some version of SkyDel. In fact, we can even use just the software to generate IQ data and utilize that in some receiver development when we're at the software level. We're going to continue to take advantage of that software architecture and deliver SkyDel to users in different ways. So we want to make sure that we can get SkyDel out to all the users that need it, whether that be a startup or whether that be a high-end military customer. We want to make sure that we have SkyDel available to them on the hardware that they are able to use. So we know that a lot of things are in the cloud nowadays. We see if we can take advantage of anything there, and we want to also extend the radios that we support. So right now, when we evaluate a software-defined radio, we have to make changes in SkyDel and make a driver to operate with that software-defined radio. So it's something that we have to do in the engineering side. So what we're looking to do is make an open source streamer where a customer with the SDR could actually write their own driver without having to use the SkyDel internals at all. And that will allow us to support many more radios.